Okay, for week 5 on the limit definition of a derivative, hopefully you opened the folder and you read the directions. So what you should have done at this point is have copied down the notes that I already have in there, all filled out. Then watched the 2 videos on Khan Academy that basically go along with the notes. So if you already have the notes filled out, then you can pay more attention to just understanding what they're saying in the video, maybe making some changes to your notes if you copy down something that you weren't sure of and now it's become clearer. And then I'm going to work through the practice problems that came after the notes. So if you haven't copied down the notes and watched the initial videos yet, I strongly recommend that you do that before watching this video. You can come back to this. Derivatives is going to be really important at the beginning of calculus. So you really want to make sure that you do a good job with this assignment and you really understand it. Okay, so again, you should already have these filled out. I'm going to start off with, these are the 2 formulas that you really want to be familiar with to work the problems. Okay, so the 2 formulas, if it just says find the derivative, so it's more open-ended. They didn't give you a specific x value or an ordered pair. There's no point given. Then this is the formula that you want to use. Okay, that's going to be the overall formula for the derivative of a given function. And then once you do have an x value or an ordered pair, you could use that formula or derivative to substitute into to find the slope of the tangent line. If you are given a specific x value or an ordered pair, then this is the formula that you want to use, where your x value represents c, right here, and y is f of c. So you would put your x value here and your y value here, okay, which makes sense for slope because it's y minus the y value you're given over x minus the x value you're given, which is just your formula for slope anyway. Okay, so you want to make sure you're clear. You need those 2 formulas. All right, so first practice. So this says find the slope of the tangent line to the graph of the function 3x minus x squared when x is negative 2. So again, they have given us a specific x value. So if that's the case, we want to use the formula that's got c in it. Okay, and so we're going to use this formula to find the slope. And when x equals negative 2, that's going to be what we use for that's how we know that we're going to use this formula, because we're given a specific x value. So the first thing you want to do is find f of c. And remember, this means c equals negative 2. Okay, so basically that means we're going to find f of negative 2 for this function. So I'm just replacing the x's with negative 2. So I've got negative 6 minus 4, which is negative 10. Okay, so what we found out that when the x coordinate is negative 2, then the ordered pair, or the point on the function, is negative 2 comma negative 10. All right, so there's different notation you can use for derivatives. I'm going to use this m sub t. This just means m is we use for slope a lot. And so this is the slope of the tangent line. Okay. And we want the limit as x approaches the c value, which of course is that x value. So the limit as x approaches negative 2. We're going to put the function here. F of x is given right here. F of x is 3x minus x squared. Minus f of c is this y value that we found that pairs with the x value. So minus negative 10 divided by x minus the c value, which is the x value that you were given. So remember, this is c comma f of c. All right, and so minus -2. All right, we're just going to clean that up a little bit. So we've got -x² plus 3x plus 10 over x plus 2. And we can factor that numerator. I tend to not like to have my x coordinate or my squared term negative, but it can be done. I find it annoying. And we can reduce, so we get -x plus 5. And then finish it off, since it's the limit as x approaches -2. Remember, when you're finding a limit algebraically, the first thing you should try is direct substitution. And so if we substitute in this -2 for x, what we're going to get, -2 plus 5, or nope, minus -2 plus 5, we end up with 7. So the slope of the tangent line is 7. Okay, so on this function, which is a parabola that turns down, at this specific point, the slope is 7. That's it. All right, find the derivative of. So that doesn't give us any kind of x value. Doesn't give us an ordered pair. So that's the other formula. Right, so that formula is the more generic one. That is the limit as x approaches, or sorry, no more x, h approaches 0 of f of x plus h minus f of x all divided by h. So in the notes, you had like x plus h minus x, and the x is canceled out. So you can simplify the formula from the notes so that there's just h in the denominator, because that's always going to happen. So we're not going to get a number from this. We're going to get an expression, okay? Sort of a new formula that we could then use if we did have an x value to plug in there. All right, so for A, I'm probably going to just use this whole space for A, and then I'll just go into extra paper for the other part. Okay, so the formula is the limit as h approaches 0 of f of x plus h. So we take this function or the expression over here, and we just replace all the x's with x plus h. So the limit as h approaches 0, so instead of x squared, x plus h squared plus 3 times x plus h plus 4 minus f of x. So minus this function. This is f of x. This is what f of x looks like when you replace all the x's with x plus h. You want to use parentheses here because you're subtracting, and you don't want to get the signs messed up. And then the whole thing's just going to be divided by h. All right, so we got to clean up this numerator. The more times you do it, the more you get used to the x plus h quantity squared and the outcome of that. So the limit as x approaches 0. When you do x plus h times x plus h, FOIL and combined like terms, it's x squared plus 2xh plus h squared every time. Plus 3x plus 3h plus 4. And then because you're subtracting f of x, you want to make sure you distribute that sign. And what you should see at that point is that everything that doesn't have an h in it should cancel out. If it doesn't, probably need to go back and figure out what went wrong. X squared and negative x squared, 3x and negative 3x, positive 4 and negative 4. Everything that didn't have an h had its opposite, so it could cancel. Okay, so here's another way to write derivative. The derivative of the function f of x is the limit as h approaches 0, and we have 2xh plus h squared plus 3h all over h. You could see at this point every single term has an h, so that reduces to 2x plus h plus 3. Okay, just took h out of every single term, so there's no more denominator. Again, direct substitution when you're finding a limit. So I'm going to directly substitute that 0 for h, and I get 2x plus 3. So I have the derivative of f of x is 2x plus 3 for the function x squared plus 3x plus 4. So what that means is that is the equation for the derivative. And so then if you said, well, what's the slope at a certain point on that curve, then I could plug that x value in there and I could tell you what the specific slope is at that specific point. Okay, let's see, part B. The reason why we're doing 3 different types of functions is because the type of function will give you different algebra that you have to worry about. Okay, so for part B, f of x equals the square root of x plus 4. Okay, so remember, we are using that formula where we're going to do the limit is x, I keep writing x, it's h. H approaches 0. First, it's f of x plus h. So rewrite your function except replace x with x plus h. Minus whatever the function is all over h. Okay, so you got to remember back to when we did limits and we had to rationalize the numerator, because that's a little bit of what's going on here. So we are going to rationalize the numerator by multiplying by the conjugate of the numerator. And if I do that in the top, I have to do it in the bottom. All right, so I have a binomial times a binomial for my numerator. So if you multiply a square root by itself, you just get what's underneath. So that's going to give me x plus h plus 4. And then when you multiply conjugates, the outer and the inner always cancel. So then I just have to do the last terms. And again, when you multiply a square root by itself, you just get what's underneath. But it's a negative times a positive. So it's minus and then what's underneath. So notice I use parentheses because I'm subtracting. So that's important. And then on the denominator, I'm just going to leave it as h times this conjugate. Okay, so to clean up in the numerator, so I have x minus x, and I have 4 minus 4. So all that I'll have left in the top is h, and then I still have that h in the bottom, times the conjugate, and the h's cancel. So what I'm left with is 1 over the conjugate. If you remember, that happened a lot when we were doing limits, but it doesn't always happen. I think somehow I wrote multiplication there instead. All right, so we are going to find the derivative by finding the limit as h approaches 0. So to direct substitution, replace that h with 0. And I have 1 over the square root of x plus 4 plus the square root of x plus 4. So the derivative is, we're using f of x, right? Is 1 over 2 times the square root of x plus 4. So that is the derivative. It's more like a formula, so that then if I want to know the slope at a specific point on this function, then I could plug it in. All right, for part C, I'm just going to get on the paper. Okay, so then we're going to look this time at what happens with a rational function. It's not a very complicated rational function, but again, the algebra will be different. Okay, so again, given no x value, given no order pair, so I want to use the formula that's the limit as h approaches 0. Okay, so first we need f of x plus h. So replace this x with x plus h minus the function as given all over h. So again, we did talk about these when we were doing limits as well. This is a complex complex fractions and fractions. So I have to actually get a common denominator up here so that I can subtract these two fractions and make this into one fraction. And then I should be able to simplify more. Okay, I don't think you can see this division bar. Okay, so the common denominator is going to be a combination of each of these, right? If it exists in one denominator, it's got to be part of the LCD. So the LCD is going to be x plus h minus 1 times x minus 1, which means that I'm going to switch to pen so you can see it better. The limit as h approaches 0. Okay, so in this first fraction, I already have x plus h minus 1, so I need x minus 1, the other denominator. And if I put it in the bottom, I have to put it in the top. And in the other fraction up here, I already have x minus 1, which means I need the other denominator, x plus h minus 1. And if I put it in the bottom, I have to put it in the top. I haven't done anything with the h on the bottom because I'm not going to need to. All right, so let me just rewrite that. So that first fraction now is x minus 1 over that LCD. I wouldn't actually multiply it or anything. Over. Sorry, my pen kind of broke for a second. X plus 1 minus 1 over the LCD. The order of those factors don't matter. Okay, so that minus is very important because I have x minus x. So the x's are going to go away. And I have negative 1 minus negative 1, which is negative 1 plus 1. So those are going to go away. So now I just have minus h. So it's the limit as h goes to 0 of negative h over the LCD. And now I am ready to find that limit. So I'm going to replace the h's with, what did I do wrong? I did some, I forgot this h down here. Okay, so this is one fraction divided by another, which means it's this fraction times this reciprocal. So instead of divided by h, it's times 1 over h. Okay, this is much better. Okay, so I have negative 1 over the LCD. Yeah, the h in the denominator is pretty important. Okay, now I can find the limit as h approaches 0 by just substituting that 0 in here, which is going to give me negative 1 over x minus 1 times x minus 1. So the derivative of this is g of x. Not that that's super important. Would be negative 1 over x minus 1 quantity squared. That is my derivative or formula, so that if I knew a specific point on this function, I could tell you the slope of the tangent line at that specific point. Okay, so that would be my answer for that one. All right. So then back to the questions. Find the equation of the line tangent to the graph of this function, f of x equals x squared plus 3x minus 4. Notice that is the same as I have right here. Okay, so I've already actually found a formula, and I have a specific point. So if you've already found the general derivative of a function, then now I could use this. So I could just replace this x with negative 2, and I could tell you what the slope is at that point. But we said before that if you're given a specific x value or a specific point, then to use that other formula that has the c. So I'm going to do that, but I'll come back to this to remind you that that was another option since we'd already found it that way. Okay, so remember this is c comma f of c, and we are going to use that formula. The limit as x approaches c of f of x, so that's what you're given, x squared plus 3x plus 4 minus f of c. Okay, well, we don't need to, like the very first problem, we had to plug the -2 into the function to get the 2, but since they gave us the whole ordered pair here, we already know that if we substitute -2 into this function, we're going to get 2. So f of c is already 2. We don't have to do that work like we did in the very first problem. And then on the bottom is x minus c, which is the x coordinate of that point. Okay. And I guess I could have written -2 here since we know what that is. All right, so this is going to be the slope of the tangent line. So the slope of the tangent line is equal to the limit as x approaches -2. On the top here, we have x squared plus 3x plus 2. And on the bottom, we have x plus 2. We can factor that numerator. That gives us x plus 2 times x plus 1, which will cancel out. So we have the slope of the tangent line, the limit as x approaches -2 of x plus 1, and direct substitution, if we plug that in there, we get -1. Okay, well, let's go back and look. What if we, since we'd already found the general derivative for that same function, if you had plugged -2 in here, you would have gotten -1. Okay, so you could always use the general formula to find the derivative and then use that with any x values that you're given to find the slope at that specific x value. Or if you already know the specific x value, the specific point, you can use the formula that uses the c and the f of c. So you've got two choices. All right, but we're not finished with this one because it didn't just say find the slope of the tangent line like number 1 did. It said find the equation of the tangent line. So this is the slope we're going to use. Well, if you have a slope and a point, you should always be able to write the equation of a line using point slope formula, which is y minus y sub 1 equals slope times x minus x sub 1, where x sub 1 and y sub 1 use that point that you know. So y minus the y coordinate of the point I know equals the slope I just found, -1, times x minus the x coordinate of the point that I'm using. So y minus 2 equals -1 times x plus 2. Y minus 2 equals -x minus 2. And then when you add the 2 to both sides, you get just y equals -x. So the answer to this question, find the equation of the line tangent to the graph at that specific point. Okay, so this is the derivative for the entire function. This is the tangent line only at the specific point -2, 2. Okay, so this would only be the tangent line at that specific point, whereas we can use this for every point on the curve, okay, to find a particular slope. All right, so if you want to pause the video and try the second practice questions and then come back, I'm going to keep going, but now would be a good time maybe to pause the video and work on them yourself and then come back and see if you got them right. Okay. So first two problems, find the slope of the tangent line to the graph of the function at the given point, write the equation of the tangent line. So this is going to be more like the last problem that we did. We are supposed to find the slope of the tangent line, but we're also supposed to write the equation of the tangent line. So it's asking for two different things, okay? So since we have the specific point, that's the limit is x, I keep getting my x goes to c of f of x minus f of c over x minus c. And remember the ordered pair is just c comma f of c. All right, so for number 1, the limit as x approaches the x value of the function minus the y value that they gave us. Remember, if they only give you the x value, then you would need to plug that x value into this function to find that y value. If you put -2 in here, you will get 7. So if they only gave me the x, I'd have to substitute the -2 in to get the 7 myself, but they gave it to me. X minus the c value, which is the x value. All right, so that's the limit as x approaches -2 x squared minus 4 over x plus 2. So x squared minus 4, that factors into x plus 2x minus 2. And when you reduce, you'll just have x minus 2. And then now that you have to do the limit part where you substitute in the negative 2. And so you get negative 4. Negative 2 minus 2 is negative 4. So that is the slope of the tangent line at that specific point. That was the first thing they asked. And then they said, okay, now find the equation of the tangent line. So the other part, you have a slope, you have a point slope form, y minus the y coordinate they gave you equals the slope you just found times x minus the x coordinate they gave you. Minus 1. So this is the other part, write the equation of the tangent line. So this is the equation of the tangent line for this function at that specific point. This is the slope of the tangent line at that specific point. All right, let's try with the square root function. Okay, so this is c comma f of c. So the limit as x approaches whatever the x value is, got the function minus the y value they gave you over x minus the x value they gave you. So this is another one. Anytime it's the square root function, you're going to use those conjugates. So we're going to rationalize the numerator by multiplying by the conjugate on both the top and the bottom. That's going to happen every time when you multiply the conjugates. Remember, the outer and the inner cancel, so it's just the first terms, which when you multiply something by itself, you just get what's underneath, and the last terms. And then the bottom you want to leave just as the factors. Don't actually try and multiply them. So it's x minus 5 over x minus 5 times the conjugate. And then the x minus 5 cancels. So the limit as x approaches 5 of 1 over the conjugate. And then you find the limit by substituting in that 5. So 1 over the square root of 5 minus 1. 5 minus 1 is 4. The square root of 4 is 2. So 1/4. Okay, that's the slope of the tangent line at that specific point. That's one part of the question, and then write the equation of the tangent line. So I've got this point and the slope, y minus the y coordinate of the point they gave me equals the slope times x minus the x coordinate of the point they gave me. And when you add 4, so you've got negative 5/4. When you add 2, well, I think I just said 4. When you add 2, that's like adding 8/4, common denominator. So negative 5/4 plus 8/4 would give you 3/4. That's the other part of your answer right there. Okay, so then it says find the first derivative. The first derivative just is the same as when it says just find the derivative. When you're in calculus, then you'll talk about first derivative, second derivative. The first derivative is what we're talking about. Okay, so nothing new. All right, so this doesn't give us any x coordinates or ordered pairs, so we are going to use the formula where h approaches 0, and we're going to just find like a general derivative sort of formula for the function. Okay, so the limit is h approaches 0. Okay, start out with x plus h, or f of x plus h. So we're going to replace this x with x plus h minus, use parentheses, okay, the function where you place x with x plus h minus the function as given and all divided by h. Okay, again, I told you you're going to have to do x plus h quantity squared a lot, so the sooner you get that memorized, the faster it will be. Distribute this subtraction sign. Everything that doesn't have an h should get crossed out, and you can see that does happen. So I have the limit as h goes to 0 of 2xh plus h squared all over h. Now everything's got an h in it, so we've got the limit as h approaches 0 of 2x plus h. Then we can do your direct substitution, and we get 2x. So the answer, the derivative of this function is 2x. Okay. All right, I'm going to switch to difference paper for number 4, just to give myself some more room. Okay, limit as h goes to 0. So first we're going to replace all the x's with x plus h. So 2 times x plus h squared minus 5 times x plus h minus 3 minus the function, use parentheses, all divided by h. Okay, x plus h quantity squared again, 2 times x squared plus 2xh plus h squared. Distribute. And then distribute this negative sign here. That's why the parentheses are so important. Still got a little bit of work to do in the numerator here. Distribute the 2x squared plus 4xh plus 2h squared. Let's see, I can go ahead and get rid of the 5x's and the 3's. Minus 2x squared. Okay, over h. And then the 2x squareds go away as well. Remember, everything that doesn't have an h should cancel. So 4xh plus 2h squared minus 5h over h. Everything has an h in it, which means that you can reduce everything by h, which means no more denominator. And at that point, that's when you can do your direct substitution for your limit, and you get 4x plus 0 minus 5. So your derivative for function number 4 is 4x minus 5. All right, number 5, your rational function. Again, the main thing is that the algebra is just a little different. So number 5, g of x equals x over x plus 1. Okay, limit as h goes to 0. So we'll replace both of these x's with x plus h over x plus h plus 1 minus the function as given, all divided by h. That's the part I forgot last time. Don't forget that. Okay, because I'm concentrating on up here, I've got to get the common denominator. So the common denominator is just going to be a combination of both of these. So I need this denominator over here. So over here, I'm going to put in the x plus 1. But if you put it in the denominator, it has to go in the numerator. And over here, I'm going to put in this denominator, which is x plus h plus 1. Okay. All right, so that's all I did, is made both denominators look the same by putting in the one from the other fraction. All right, then I got to clean that up. Okay, so I have x plus h times x plus 1. So you actually want to FOIL that. That'll give you x squared plus x plus hx plus h over the common denominator minus, distribute here, not FOIL, distribute x squared plus xh plus x over that common denominator. And now I can actually make that into one fraction. So I've got x squared minus x squared. I've got x minus x. So, and then I've got hx minus xh. Hx and xh are the same thing. Okay, hx minus xh, same thing. So it just ends up being h. All right, and then this is like over 1. So when you take this fraction that I finally simplified up here and you divide by h, that's the same as multiplying times 1 over h, and the h's cancel. So you have the limit as h goes to 0 of 1 over that common denominator. Then you can find the limit by putting in the direct substitution. So you get 1 over x plus 1 squared. So the derivative of this function is 1 over the quantity x plus 1 squared. All right, and one more square root function. So let's see, this is number 6, g of x equals the square root of x minus 4. So square root function. So the limit as h goes to 0, replace x with x plus h minus the function all over h. So square root function is always going to come down to having to rationalize with the conjugate. So I'm going to multiply times x plus h minus 4 plus square root of x minus 4, but on the top and the bottom. Okay, remind you again that when we multiply conjugates, it's the outer and the inner cancel. And when you multiply something by a square root by itself, you just get what's underneath. Then the outer and the inner cancel. And in the last terms, it's a negative times a positive, so put minus. Then put some parentheses, multiply the square root by itself, so you just write down what's underneath those parentheses. Very important. And then down here in the bottom, I'm just writing down h times the conjugate. And you should be able to see that in the numerator, you have x minus x and negative 4 plus 4. So that numerator just simplifies to h, which has something that you have in the denominator that will cancel out. So the limit as x approaches 8, as h approaches 0, over the conjugate. Doesn't always equal 1 over the conjugate, but as you can see, it happens a lot in the problems we're doing. Then you can directly substitute the 0. And so you end up with the derivative of this function is 1 over square root of x minus 4 plus square root of x plus 4 is 2 times the square root of x minus 4. And that is your derivative for that one. Okay, so hopefully you are good to go. There is, in the one document, there's warm-up problems and then a key for that. So if you want to spend some time working those and see if you get those right before you do the assignment, I really want these assignments to be good and showing me that you understand, because it's so important for calculus.